Good. So, hello everyone. Thanks for having me at your evening meeting. And today we're going to talk about monitoring SQL Server without breaking the bank. Sorry for the SQL Saturday template. I didn't have the time to change it, but you probably know SQL Saturday as well. And before we go, a few words about me. My name is Gianluca Sartori. I'm an independent SQL Server consultant. I've been working with SQL Server for a very long time. It's been since version 7, so a long time ago. I'm a data platform MVP. Currently, I'm working as a DBA at a famous Formula One team in Italy, which will not win the championship this year, maybe not next year, hopefully in 2 years. And if you want to read my blog, you can find it at spaghettidba.com. My handle on Twitter is at spaghettidba. So let's go. What's the agenda for today? First of all, we are going to see why we do monitoring. We will see that we have some needs, and we will have to cover those needs with different options. And the easiest one is obviously go out on the market and buy something. But we will also see that we have some options that we can set up using what's already inside SQL Server. And then we will turn to some community options, so open source or free tools. And we will choose one of those, which is the tick stack, and we will see what it is, what we have inside, and then we will try and use it. And I'll show you how easy it is to use it. Okay, so first of all, we are a bunch of DBAs probably, and if just a note for you, if you take the backups, you're a DBA. So if you're in charge of that, welcome to the DBA crowd. So if you're a DBA, you need to monitor your servers. And you do this because you have to answer questions. And people will come to you with questions like, hey, what happened tonight? Because I had an ETL job that was running on the server and it started to go slower and slower and slower. How can I know what was happening at the time? Well, the easy answer is that you cannot. If you turn to your server and you run some of your magic queries to know what's happening, you can only see what's happening right now. So the only way to know this in the past is to have some kind of monitoring active that records numbers and some other information over time. So you can go back at the specific time where a problem happened, and you can go there and see what was happening at that time and what caused the issue. And once you have some monitoring in place, you can now answer questions about troubleshooting. But other questions may have to do with performance. So you see that your system is consuming a lot of CPU or a lot of disk I/O. And what you can do with monitoring is go and see what is consuming those resources and start tuning from there. Other questions may have to do with capacity planning. So when will my disk space finish? When will my CPU capacity be used 100%? The only way to know this is to record how the system is behaving over time and predict what it will look like in a month, 3 months, 1 year, and know in advance when resources will be completely used. Other things may have to do with knowing if the system is behaving normally. So sometimes users call you up and say, hey, everything is slow. Well, fast and slow are two relative concepts, and they have to be relative to normality. And the only way to know what is normal or not normal is recording a baseline. So your baseline is what happens on your system on a normal day without major incidents. That's your baseline. So when somebody calls and said everything is slow, you can go back to your monitoring system and say, no, I don't think so. Everything is running smoothly. So you may have some different issue. Or maybe you can say, oh, you're right. We have an abnormal CPU consumption, and you can go and hunt that down. And sometimes all you want to do is alerting. So when things start to go wrong, you want to have something that calls you, that alerts you before things start to get really bad and people call you. Okay, so how do you do this? The easiest way to implement monitoring is to go there and buy a product from some of the players out there. So we have people like Sentry or SolarWinds. Well, actually, they just merged, so I will have to update this slide for the future. And then we have others like Quest or Idera, Redgate, Epic. These are some of the names out there, and they do monitoring specifically for SQL Server. So their solutions have a big value because they know exactly what to capture, how to present the data they collect, and they can really help you with all the questions that we've seen in the previous slide. So they really take you directly to the point when you're troubleshooting or observing your system. There's only one downside to all of this. They cost a lot of money. Just to give you a rough idea, the top players in this area will charge you something like 2,000 euros per instance for monitoring tools, and that's a lot of money. So if you have like 10 servers, that could work. If you have 20 servers, maybe that works. If you have 100, probably doesn't. 1,000, it surely doesn't work. So you may want to do something different. One of the options is using what's already inside SQL Server. We have tools for this. We have tools for monitoring the state of SQL Server already inside the products. They're the bricks for building a homemade solution. So what can you do? You can use SQL trace or extended events to capture interesting events as they happen on your instance. You can use SQL Server Agent alerts to receive emails when things start to go wrong on your server. You also have the ability to use SSMS to keep an eye on your servers. So one of the possibilities is using the activity monitor, which is not perfect, but it helps you see an overview of performance of your server. You have some reports built into Management Studio that can help you monitor performance. And another possibility is using the data collector. So the data collector is one of the features that Microsoft at some point decided to include in SQL Server to be the counterpart to some of the features that you had in some other relational database products like Oracle. Those products included their own performance monitoring solution, so wanted to include something in SQL Server as well. So they created the data collector. Basically, it's a solution based on integration services packages. They collect some data, and then this data is uploaded to a relational database that is called the management data warehouse. And this database contains all these performance metrics that you can go and query with some reports built into Management Studio. It shows some performance data like you see here. This is one of the reports built into SSMS, and it is kind of working for troubleshooting. So you can go back in time and see what performance was like at that time. You can see which queries were running. You can see wait stats and some other things like performance counters. So it does help you with some of this, but it has a couple of downsides. First of all, it's totally unreliable. Sometimes it stops working, it stops collecting the data, even if you think it's still running. It is based on some jobs that appear to be running, but actually they're not uploading any data to the management data warehouse. Also, if you are uploading performance data from multiple servers to a single management data warehouse, the reports will start to be incredibly slow. Also, it has no alerting, so the only thing you can do is have a look, keep an eye on the reports, but you cannot receive alerts when things start to go wrong on your server. And it's also really hard to customize or extend. So if you want to capture something else, some metric that is not included in the standard, you really have to do a lot of work for that. And the main reason why I don't recommend using the data collector is because it's now deprecated. So Microsoft is still including the data collector in SQL Server. It still works, but it's been deprecated. So they're not adding any new features. They haven't actually added anything in the last few versions of SQL Server. And now it's completely at the end of its life as a feature. So what can you do? Another possibility is to go and use some of the tools that you can find from the community. Here we have two families of tools, two kinds of tools. Those that were built specifically for SQL servers, and some generic monitoring solutions that also include plugins to monitor SQL Server. So regarding specific SQL Server monitoring solutions, here the only one I can really recommend is SQL Watch. This is an open source solution based on the collection of data using SQL Server agent jobs. This data is uploaded to a database on the same instance that you are monitoring, and then you can use some tools on top to do visualizations and alerting. You can use Power BI or Grafana to display the data captured by SQL Watch. And it's a very interesting solution. I suggest that you go and take a look because it's really progressing well. It's quite new, so it might have some rough edges, but it's really improving with each release. And what else can you use that was built specifically for SQL Server? Well, obviously you have dbatools. In case you don't know it, dbatools is a PowerShell module built specifically for SQL Server. So it includes a lot of features for working with SQL Server databases. And basically, it's like SSMS, but in PowerShell. It's perfect for automation. It does everything that you can do from a GUI and much more. And it is great for scripting your maintenance and management of SQL servers. And among the things it can do, there's also the ability to capture data across your whole SQL Server estate and upload that data to a centralized database that you can use for reporting on the metrics that you really care about. So you can build a monitoring solution based entirely or mainly on dbatools. It really does work. And other options, I included two projects of mine here. The first one is called Extended T-SQL Collector. And basically, this is a set of tools to extend the functionalities of the data collector, but I really don't recommend going down the route of using the data collector now because, as I said, it's deprecated, so not a great solution. If you already have it in place, maybe it can help you extending the features of the data collector. Another possibility here is using XC Smart Target, which is again an open source project of mine. And this is a way of interacting with extended events sessions without having to write any code. All you have to do is configure what you want XC Smart Target to do, and it will handle the events coming from extended events sessions with writing this data to a database or sending emails. It can do many things that can help you setting up a monitoring solution. Another possibility is to use some generic monitoring tools that were initially built for monitoring operating system or similar parts of your infrastructure. So tools in this area are like Nagios or Zabbix, and they also include plugins for monitoring SQL Server. And one interesting trend that has appeared in the last few years is the use of analytic platforms that also include plugins to extract data from SQL servers and visualize these data using the capabilities of the analytic platforms. So in this area, what will you find? Things like Elasticsearch for the backend, so the database for storing data, and Kibana for visualizing the data with very powerful dashboards. You can do the same with Prometheus and Grafana, or another possibility is using the tick stack, which is the one that I will show you in this session. So let's see what we have in this tick stack. First of all, tick stands for the initials of the tools inside this software stack in this solution. So the tools are Telegraf, InfluxDB, Chronograf, and Kapacitor. All these tools were built by InfluxData, and this company has all its tools open source on GitHub, so you can go and see the source code, contribute to the project, and it's a really cool platform. Also, it is built, it is coded in the Go language, so you can build it for different platforms. You can build it for Windows, for Linux, for Mac OS. So you have a lot of possibilities there. The first tool in the stack is InfluxDB. It's the database that stores all your data that you collect for your monitoring solution. It's a database, but it's not a relational database. It's a time series database, one of those databases that you would call NoSQL. As we said, it is written in Go, and it is optimized for storing data that comes with a time dimension, with a time attribute. So all the data that we use, that we collect for monitoring, obviously has a time attribute, so it is perfect for storing in a time series database. So InfluxDB is a very good choice for storing monitoring data. It is not a relational database, it's a NoSQL database, so obviously what we cannot use to query it is SQL. We can use two different languages. The first one is called InfluxQL. It is very similar to SQL. It has some constructs that are similar to what we find in SQL. So we have select, from, where, group by. All of that is also found in InfluxQL, but it also has some additional features that obviously are specific to time series databases that we won't find in regular relational databases. There's also a second query language, which is called Flux, and it's a totally different syntax. It is more similar to JavaScript or LINQ. It has this weird syntax with curly braces and arrows. So it looks a bit like LINQ, but again, it is a different thing. I still have to learn this one. It's quite new. It is meant to be used with newer releases of InfluxDB. The next big release is version 2, which is not available yet. There's a release candidate, but we're still using 1.9 now. Okay, so the next piece of the puzzle is called Telegraf. This is the data collection agent. So the process that takes care of collecting the data from the sources. And we can use it to extract data from multiple sources. So the operating system is one of the things you can monitor with Telegraf. You can also use it to monitor relational databases like SQL Server, Oracle, Postgres, and you can use it to monitor network, message queues, applications, web servers. The way this works is through plugins. So Telegraf is a generic monitoring solution, general monitoring agent, and it uses plugins to attach to different sources. And it uploads the data to an InfluxDB database. So it knows how to talk with an InfluxDB database on the back end. The next piece of the puzzle is called Chronograf. These tools, it is a bit like SSMS in SQL Server. It serves two usages. It is used for administering the software stack. So you can use it to manage InfluxDB and Kapacitor, which is the next tool we will talk about. And you can also use it to query the data that you have inside your InfluxDB database. And Chronograf displays the data inside the InfluxDB database, but as we said, it is usually numeric data recorded across many samples over time. So it is good for visualizing this data as charts. So one of the capabilities of Chronograf is to visualize data with charts, and you can combine multiple charts and dashboards. You can save these dashboards on Chronograf so that you can go back to these dashboards at a later time to visualize the data in InfluxDB database. So it is both a tool for managing the software stack and a tool for visualizing the data inside InfluxDB. Good, so the last piece of the puzzle is called Kapacitor. This is a data processing engine, and basically it listens on the data you write to the InfluxDB database. What you do is you define some topics, and you can publish the data that you collect to these topics. Basically, think of these like triggers, like concept behind the triggers. And when you write this data to your InfluxDB database, when you define the topics, the data that goes to these topics triggers a capacitor, which uses some plugins to perform actions on the data received on the topics. So among the things you can do is transform the data to save it back to different tables on your InfluxDB database, or you can use it to notify that some data has been written to the database, and you can use different plugins to notify, to alert that new data has been received. So you have plugins for emails or for Slack, for Telegram, so many options here for alerting. Okay, so we have another piece of the puzzle, which is not strictly part of the TIG stack. This one is called Grafana, and this is a reason why some people call it the TIG stack, because nobody really uses Chronograf for dashboarding, because a much better alternative exists, and it's called Grafana. So it's an analytics platform that you can use to build your dashboards, and you can build your dashboard on top of InfluxDB directly, because it has native support for InfluxDB, and is really easy to use. You can set up a dashboard, a very effective dashboard with just a couple of clicks. And you can also use it to grab your data from other sources like SQL Server or any other database, including relational databases, NoSQL databases. It is really easy to create dashboards using Grafana. So we have a question from Benny. So how do you define the balance between alerting all the things and not alerting enough? It is complicated. And the main rule, the rule of thumb here is that alerts need to be actionable. So when you receive an alert, it's because you need to do something. If the alert is not telling you that you have to do something, then it doesn't need to be an alert. And you can save that to a database where you can go and read the events, but it doesn't need to be an alert. Otherwise, what happens is that you receive too many alerts and you stop caring, you stop reading those alerts. You set up a rule in your Outlook, and all the alerts go to the alert folder where nobody reads them. So that's why you need to have actionable alerts. Okay, so another thing that is really interesting with Grafana is the fact that you don't have to build your own dashboard. You have the, oh, no, go away. Okay. You have the possibility to use some of the built-in dashboards from the community. So as we said, we have plugins for Telegraf that are capable of collecting data from several sources. And obviously, when you use the plugins, you know what the plugins output on the InfluxDB database. So you know the shape of the data and you can build dashboards on top. So for each of the plugins found in Telegraf, you will also find Grafana community dashboards that show, that display the data collected by that plugin in Telegraf. Okay, so the overall architecture of the tech stack looks like this. You have your database, you have Telegraf that collects the data from your database, then you have InfluxDB where you store all that data, and you have Kapacitor that listens for data on specific topics and sends alerts when this data arrives. And then you can use Chronograf to query and explore the data, and Grafana to build dashboards on top of your InfluxDB data. Good, so looks complicated? No, it isn't. And I will show you how easy it is to use the tech stack. So first of all, we will have to install InfluxDB. And this is pretty straightforward. All you have to do is download InfluxDB. You will have to unzip the zip archive to someplace, and then probably you want that running as a service. So let's try to do that. What I have here is rather vanilla Windows server, and what I have here is some demos. So I'm going to use some PowerShell scripts to do all the things that we need to do. First of all, I want to delete any data from previous demos. So I'm going to set up my environment to be as clean as possible. And then we will have to download InfluxDB. I'm going to go and download it. I will have to download from Influx Data. And this is the latest release today. So 1.8.3. Obviously, you have to download it for your operating system. I will use Windows for this, but because I'm familiar with Windows. But if you're familiar with Linux, just go ahead and do it. The next release of InfluxDB will be Linux only. There's no plan to do a Windows release, so it's going to be a huge leap for those like me who don't know Linux too well. Oh, well, anyway, I'm extracting this InfluxDB to my destination, which is the ctick folder. So let's see what we have here. ctick, I have this InfluxDB 1.8.3. Let's go inside here. And as you can see, all you have is a few executables. And the one that we need to run is InfluxD. So the Influx daemon that runs in the background. So if I run that, oh wait, this is the wrong one. So it's 1.8.3. I was running the previous version. So if I run this one, As you see, we have a sort of a character-based splash, and it's InfluxDB running. So cool, it's running. But obviously, if I close this window, InfluxDB is not running anymore. So probably I want to have this running as a service. So in order to run it as a service, we need to have some hooks. Know that in Windows, services need to have a hook for receiving start, stop, and pause messages. And any regular executable cannot be used as a service unless you use a wrapper. So one of those wrappers is NSSM. It's the non-sucking service manager. Why this name? Because in the past, Microsoft created a service wrapper that was called SRV-Any. And SRV-Any basically used to suck a lot. What it did, no, it's not perfect, Rob. Basically, SRV-Any had the ability to run any executable as a service. But what it did is just start the executable. And if it crashed 1 second after starting, no problem. Service is started and working because SRV-Any was running, but the executable behind was dead. So NSSM is an open source alternative to SRV-Any, and it doesn't suck. So it monitors the underlying executable and takes care of notifying Windows when it crashes. So it does everything a sensible service manager wrapper would do. So what you do to work with NSSM is this. You download it, you unzip it, and it goes into CTIG NSSM, and Win64, it's a single executable. So all we have to do is, okay, I will extract it, and I will use it to install a service called InfluxDB. So I will use 2 arguments, install and name of the service. So let's run that, and a little GUI appears. And what I do here is I select the path to the executable I want. So it's InfluxD. And let's see if it's the correct one. No, it's the wrong one. So let's go to InfluxDB, InfluxD. And this is the one I want to run. And if I have some arguments, I can specify them here, like the path to the configuration file and so on. So service name is InfluxDB, so I can go here and click install service, and I have a service running. So now I can see my service into the services applet in Windows, and I can see if I have InfluxDB, and it's here, so I can start it, and yay, it's running. Good. I could also use it to start my service instead of going to the services applet, or stop the service with stop InfluxDB, but no problem. We can leave it running. So now the next part of the stack, we need to go and configure Telegraf. So again, it's a matter of downloading Telegraf, unzipping the archive, and now we need to do a couple of things. So Telegraf is where we will configure what we capture and where we store the data that we capture. So the minimum we have to configure is where to save a log. This will come handy when things are not configured correctly. And we will have to configure which SQL servers to monitor and where to write the data. So where is the InfluxDB with the database we want to use for writing? Okay, let's do that. It's super easy again. So as we said, it's a matter of downloading Telegraf. So let's run that. And I will extract this archive to CTIC. So again, let's have a look at what's inside CTIC and Telegraf. Oh, it went to a different folder. Too bad. Okay, so how can I fix this? I'm gonna do this. My Telegraf folder still contains the older version, so I'm gonna rename this one. Okay, so we have Telegraf and telegraf.conf. And what can we do to configure Telegraf? We have the possibility to generate a configuration file based on all the available configuration options for Telegraf. So this comes handy when we have to use one of the plugins and we don't know which configuration options it accepts. So there's a way to do that. We just need to invoke Telegraf with the config, with a config switch, and we can redirect the output to a file that we will call telegraf_full.conf_temp. Why this name? Because we will have to convert this file to UTF-8, because when you redirect the output in Windows, it creates a text file with UTF-16, which is not understood by Telegraf itself. So we will have to use PowerShell to change the encoding of the file. So we can now remove the old file and we can use code to see what's inside the configuration file that we have generated. And now you will see that we have a file that contains all the available configuration options for a Telegraf, and we will spend the next 3 hours talking about all of them. No, obviously we won't. As you can see, we have 7,000 lines of configuration file, which is absolutely insane. So we probably don't want to deal with that. There's a way to restrict what we will have in the configuration file to only the plugins that we are using. So we can specify an input filter SQL Server and output filter InfluxDB, which are the input and output bits that we are willing to use. So let's do that again. And again, we need to change the encoding from UTF-16. And now we have, again, yes, please. Oh, I didn't specify code, so sorry. Now we have 800 lines of configuration, which is still a lot, but much more manageable. So we can use this. Let's see what we need to fill in this configuration file. So first of all, we need to specify where to write the file. So I could type here ctick telegraf dot log. And then, no, thanks, I'm not going to install updates to code during a session. And what else? You have to specify where to write the data on InfluxDB. So we have an InfluxDB here running. So all we have to do is uncomment the line for an InfluxDB listening on localhost port 8086. And then we have the name of the database. You can call it Telegraf, works for me. And what else? You have to specify, well, a username and a password. So username is Telegraf, and I'm going to specify a password. So this will become the password for this database, which will be created by Telegraf itself when it runs. Somewhere there's how often it writes to here we go, the flush interval, how often it writes to InfluxDB. And also we can control how often it queries the data from the sources, from the inputs. And again, it's 10 seconds, so you can go and change it. 10 seconds looks reasonable for me. So now we need to configure the input. So we configured the output. We just need to find the configuration part for SQL Server. It's a bit of scrolling, and here you have some processing for the data you connect. Okay, aggregator plugins, no, not interesting. Oh, input plugins. So SQL Server. All you have to do here is specify the list of the servers you want to monitor. So in this case, it's local host. I have a SQL Server running here. Runs on default port. I don't want to use SQL authentication, works with Windows authentication, so I'm good to go. And okay, I can enable different kinds of queries. There are some queries for Azure SQL DB, some for SQL Server, some for managed instance. And this is optional, but otherwise I will use version 2 of the queries. There are these sets of queries. I'm okay with version 2. So you don't have to specify all the queries because the plugin already knows what to collect. So all I will have to do is, in case, decide which queries to exclude from my collection. In this case, I don't want to collect data for the schedulers, for example. Okay, I configured everything I had to configure for my Telegraf. Now, in order to see whether it's working or not, I can use the -config option to pass the path to the configuration file and the -test option to see whether it's working or not. It should output all the data to the standard output, and in fact it does. So all that you see here is what is called the line protocol. So this is how the data is understood by Telegraf and also by InfluxDB. And it contains all the data that I told it to collect. Good, so all I have to do now is start Telegraf so that it uses the configuration file to collect the data and write it to my InfluxDB. And now it is flushing the data to my InfluxDB. Maybe I want to run it as a service. Here is how you do it. It doesn't need to use an SSM. It has the native ability to run as a service. I don't want to do that. I'm okay with having it as an interactive window here, just for this demo. Now I want to see whether I have some data in my database. So I can go here and use InfluxDB, and I will use the Influx, which is the command line client for querying the database. And I can tell it show databases, and it says it has a Telegraf database. So it worked. I have some data inside, and I can also say use Telegraf. And now I can tell it show measurements. These are the tables in InfluxDB, and it is writing some data. So it is actually there's some data flowing to my InfluxDB database. So cool, it is working. Okay, so the other parts of the stack, I could also see this data from Chronograf. Chronograf, I can go ahead and, okay, it is good for exploring data, so I can go here, download it again, and expand it. Takes a while. It's a big archive. Okay. And I can run it. And it is running on the background, and it is a web application. So I browse it by opening a browser to my local host. So when I land here for the first time, I need to specify a username and password, and the name of the database is Telegraf, so I can add a connection to my InfluxDB. And it is working, so I will skip creating dashboard. I will skip this as well, and I can show you that I have a connection here to my InfluxDB, and I can use it to explore the data. And this is a typical InfluxQL query. So as you can see, you have select, you have from, where, group by. And the good news is you don't have to learn this. You can use the GUI to compose your queries, and this is what I did here. So you can go here and select which counters you want. I'm using batch requests for a second here. I can use active transactions, and it adds that to your InfluxQL query. So it does work without having to learn this InfluxQL language. So this is cool for exploring the data that you have in your InfluxDB database. And what else? Well, a few terminology here. What you call tables in SQL DB is called a measurement in InfluxDB. What you call a column in a SQL database, it's a tag or a field in InfluxDB, depending on whether it is used for filtering and aggregating, or it is a value, a numeric value that you have in your table. And what you call a row in SQL DB, it's a point in InfluxDB. Good. So next piece of the puzzle is Grafana. So again, all you have to do is download and install it. And let's see how you do it. So Grafana, let's download that. And it's again a big archive. So when this is finished, we will run it, and it's an archive to expand. And again, it's a web application. We will have to configure it before we can use it. So in this case, we will use defaults ini, which is the one shipped with Grafana, and we can make a copy and use the copy as our configuration file. So let's go ahead and do that. Wow, it takes a while to expand it. Okay, so now we can use this configuration file, and all we have to do here is maybe change the port where it listens. We can change it to whatever we want, so 8080 maybe, or whatever suits you. But there are a lot of things you can configure here as well. This is a big file again. So when you start the process, it listens in the background. Now it is building the internal database for Grafana, and now it is listening. So all we have to do is open a browser, and here we have on Grafana. Default credentials are admin. So we log in, and it says, oh, you need to change that, but we're skipping. we will add a data source. We add a data source to InfluxDB, and this is the URL, so localhost, and the database is called Telegraf, and Telegraf is the user, and Telegraf is the password. So save and test, it works. We have a data source that is working here. So now we can go and start building a new dashboard, but we don't want to do that because we're lazy. So we'll download one of the dashboards from grafana.com. So there's a lot of dashboards on grafana.com. If you search for SQL Server, you will find some dashboards. This is one that I really like. It's this one from Jonathan Ryu. How does it look like? Oh, looks good. Oh, yeah, he has some data. So, okay, I'm okay with this one. Just copy the URL, and then you go to your Grafana, you paste the URL, and it loads immediately. All you have to do is select your InfluxDB database, import the dashboard, boom, you're done. You are monitoring your SQL Server. And if you don't like this, you can go and edit, but just out of the box, this dashboard shows you some data about your SQL servers. It's not perfect, but it's good. And it came for free, so it's all open source. Good, so what else can you do? We're running out of time, so just a couple of things I will show you. And with Grafana, you can also configure alerts directly on your dashboard. So you can select some of the metrics that you have in your dashboard and select one of the notification channels to alert when the counter goes above a certain threshold or something appears there. There's a Docker setup. Yes, there is, of course. I'm not very good with Docker. Next version of this is going to be using Docker. You can also set up continuous queries that are scheduled queries that will do stuff in the background. So you can take the data that you capture very often, like every 10 seconds, and you can downsample that to keep it for a longer time. So instead of keeping CPU every 10 seconds for 2 years, you can keep it for like 2 weeks, because it's where you do troubleshooting, and you can aggregate that by the hour and keep it for 2 years, and that's a lot of downsampling that reduces a lot the size of your data that you are keeping for a long time. And you can build the dashboards on top of the aggregated and downsampled data. So you can do a lot of stuff on top of that, and I can show you what it looks like when you finish working on that. This is a monitoring solution that we have, and you have dashboards for your servers. You can go here, have dashboard for CPU weight stats, the activity, and monitor TempDB usage, database size over time. You can see database IO. You can see the queries running at a particular point in time. You can also see what else? Query stats over time, and see what they look like, ranked by worker time, and see CPUs. That's super responsive, super easy to set up. Obviously, you have to work a lot on the dashboard side, but it's absolutely doable. So going back to the needs that we outlined at the beginning of the session, for troubleshooting, we can use Grafana dashboard. And you can combine that with some standard dashboards, community dashboards that you download from the web, plus custom dashboards that you can build on top of any of the metrics you collect. For performance tuning, also you can use your dashboards as we did, starting from query stats to know exactly where to start tuning. For capacity planning, we can use continuous queries to aggregate and downsample data over time and keep it over a longer retention to see what the growth trends are. For baselining, you can do the same. So you know exactly how a normal day looks like by looking at your downsampled data. And for alerting, you can use Kapacitor for complex scripts or Grafana for the built-in alerting. And if you also want to connect it to extended events, there's a way to collect data from extended events using XC Smart Target and upload that data on an InfluxDB database. So you can also use it for uploading to InfluxDB or even alerting in real time on the extended events data. Obviously, there's a lot going on here, but I will leave you with some resources to expand your knowledge. So link to Influx Data, there's a lot of documentation here to digest. Link to an SSM, link to Grafana. And also, there's a link here to a blog post of mine that shows you how to collect some data to a SQL database using dbatools. And a link to XC Smart Target, the tool for capturing data from extended events. And if you have questions, go ahead and ask them. And obviously, you can always shoot me an email. I'm slow to respond, but I do reply to everyone. Promised.